Hey there, 8th grade and Eli. We're going to be doing lesson 11 today, where they're going to have us multiply and divide rational expressions. So just a quick review from past years. When you're multiplying fractions, right, you can look for cross pairs and divide by a number if you can. For instance, like this 8 and 12, we can both divide by 4, right? And the 6 and 15, we can both divide by 3. And then that makes it a lot easier to solve, right? We can do the same thing with rational expressions. We can look at the cross pairs, and if there's anything we can reduce down, let's do it. So let's look at these cross pairs. Notice we can divide out an r on both of these cross pairs, so that's gone, and this would just be r to the first, right? And then if we look at this cross pair, we can divide out 3t, right? And so this would just become plain old just t to the first. And we can divide out, and this would just be gone, right? And then we could divide out a 3. So I'm just going to rewrite what we have just so it's not too confusing. But this one was just left r to the x, and this was just 1, right? It was gone. And then when we divided out this way, we ended up with just like t to the first and 1, right? Over, and then we divided by 3, right? So notice how easy we made this problem by dividing out things from our cross pairs. So now we just end up with t, r, x on top, and then 3 on the bottom. And we're done. There's our final answer after we multiply across. So let's do one more. Sometimes you'll have to factor some things out. So like notice on this bottom part, if I just rewrite right away, notice, let's do this cross pair first. I think it's always just easiest to rewrite, otherwise it gets really messy. If we divide out an a, this would just become 1, right? And this would just become a. Okay, and then going this way, let's factor this bottom right one first. So this would be what? This would be like a plus 4 and a minus 2, right? Would give us that. Those would multiply together to give us -8. Okay, and so notice then, if that's the bottom right, we can cancel out an a4, a plus 4. So this just becomes 1, and all that's left on this bottom is a minus 2, right? So now if we multiply across, we get 1 over, and then we take this a times both of the parts, this times both of these parts, right? Because it's really like this is what we're doing. And so we get a squared minus 2a. And there we go. All right, let's do one more that's a little more complicated. Notice if I factor this first one, I'd have y minus 4, y plus 1, right? This top left. And notice in this bottom right, I can divide out a y, right? So let's do that. That would give us y minus 4. And then notice this pair going diagonally, we can cancel out. And then notice we can now cancel out a y minus 4 on both of these. So notice what we have left. Not much at all. We have on the top y plus 1 times 1, so we just have y plus 1 up here. And then notice on the bottom we just have 1 times y. And then we can't divide down anymore because this is a monomial chunk, so we can't divide out a y in this last section. We have nothing with this bottom y. So there's our final answer, y plus 1 over y. All right, you guys remember how to divide fractions, right? We have to flip the second one. So don't forget, if they're dividing, they're going to switch to dividing for a little bit. Flip the second one and make it a multiplying problem. Then you're going to notice there are definitely some things we can cross multiply or cross pair and divide out. So for instance, I can take a 4 out of this cross pair, right? 1 and 3, okay? And then this other pair, we can divide out an n, right? So this would become n to the second. And then we can also divide out 5. So this would become, what, 3, and this would become 5. So notice we end up with 5, is all that's left on top. And then we have 3 times 3, so 9, n to the second. And there we are. They think it's going to be tricky for you to divide a rational expression, right, a fraction with variables, by a polynomial, not a non-fraction, but really all it is just putting your polynomial over 1. And then since we're dividing, we should flip, right? So let's do that. So 2x plus 6 over x squared. Let's flip this, times 1 over x plus 3. And then notice we can divide out a 2 on this top section, so let's do that. So if we divide out a 2, we'd have x plus 3. Now you're noticing a piece we can cancel out, right? And so if we cancel out those x plus 3's, all that's left on top is 2 over x squared is all that's left on the bottom. Sometimes you might have to factor a couple pieces and then divide. No big deal, you've got this. So first of all, let's flip, right? So let's just go ahead and flip this right away and put it y minus 8 over y squared minus 9, and then we're going to be multiplying, right? And then notice a couple things. We can definitely factor this bottom left one, right? This would become, y minus 8, y minus 2, right? This bottom left one. And then notice this one over here is a difference of squares. So this bottom could become y plus 3, y minus 3. So let's just regroup. Let's regroup a little bit just to organize our thoughts here. We have y minus 3 on top, y minus 8, y minus 2 on the bottom now after we've factored, right? And we're multiplying that times y minus 8 over y plus 3, y minus 3. I'm just regrouping after doing all that factoring. Sometimes it's helpful to do that or it gets way too messy. Okay, notice there are some things we can definitely cancel out then. We can cancel out these y minus 8s. We can cancel out these y minus 3s. So all that's left on the top is 1, right? And then on the bottom, all that's left is y minus 2 times y plus 3, which we have to just leave. And so there's our final answer when all is said and done. Okay, they're going to bring back something from your past today, dimensional analysis, because this is very similar to what we're doing with rational functions here, rational expressions, I should say. And so remember these, we always have to convert using multiple steps. So I do expect you to do these these dimensional analysis problems. Number 5 and 6 will be very much like this one that we're about to do, and we'll do one of those assignment problems with you. So I want to see you do your work this way, so show your work. There are different ways to solve them, but this is definitely a skill you're going to use in like chemistry in high school and beyond, okay? So they want to make sure that you know how to do this. So it says a woman won a ski racing championship by finishing an 88-kilometer course in 51.23 minutes, okay? And they want us to convert that to miles per hour. Remember how to do this? So the first thing we need to do is we need to change kilometers into miles, right? And then we'll turn minutes into hours. So remember the label you want to change, you always bring over and diagonally. And then you want to change it into the new label by putting it on top, right? And so notice they give us a hint here. 1 kilometer is about 0.62 miles. Okay, good. So now we've successfully changed kilometers into miles. Now let's change minutes into hours, right? Because we wanted miles per hour. So minutes was on the bottom, right down here. So we're going to bring that up in diagonal. And we want to change minutes into hours. Well, what's the conversion between those? There are 60 minutes in 1 hour. And then we're done. And you can double check that you have the right labels by canceling out labels, right? So notice I can cancel out minutes and minutes. And notice that all that's left is miles and hours, which is exactly what we wanted. And so then you can pull out your calculator and pop those numbers in. I'll do that right now. On the top, we have 88 times 0.62 times 60, which gives us 3,273.6. And on the bottom, we have 51.23. So if I divide those, 51.23, I end up with about 63.9. Which I believe, just double checking what the book has, yep, 63.9 miles per hour. Okay. Let's do number 5 together. Number 5 is one of those two-dimensional analysis ones. You have 5 and 6 today as your two-dimensional analysis ones. It says the slowest land mammal is the three-toed sloth. It travels 0.707 miles per hour. Very slow. Jessica actually had that in her animal report this year. What is the speed in feet per minute? All right, so we've got 0.7, one extra 0 there, miles for every 1 hour, right? And we want to change it into feet per minute, okay? So let's change miles to feet first. So we're going to bring miles down and over, right? Do you know the conversion between those? Some of you, I think, have that memorized. 5,280 feet is 1 mile, okay? Then, so we've accomplished getting into feet, right? Now we need to get into minutes, all right? Let's bring the hours up. And we want minute, okay? So we know that there are 60 minutes in 1 hour. And then we simply just have to multiply. On the bottom, I know I've got 60. 5,280 on the top times 0.07 would give us 369.6. So if we divide those out, we end up with about 6.16 feet per minute, which was the label that they wanted us to have. And notice if I go back in and I cancel out my labels, I notice that I have only feet and minute left, so I know I did it correctly, okay? So number 6, you'll do that same way. Don't forget to show the dimensional analysis. I know there are other ways to do it, but they wanted you to practice that today because that's a future skill you'll need in math and in chemistry and beyond. Have a good day, guys. Hopefully that gets you off to a good start.